Hello students, welcome back. We went through some review, elementary differentiation. Now the next topic is product and quotient rules. Here's a product rule. The derivative of sum is the sum of the derivative, yes, but derivative of product is not the product of derivative. We have something heck of a lot more complicated. U prime v plus uv prime, the derivative of the first function times second function, plus first function times the derivative of the second function. Now, there are people who use some alternative expression as well. I've seen this a lot. This one versus that one over there. They're the same. Multiplication is commutative and addition is also commutative. So this expression here and that expression down here are the same. Which one do you prefer? Well, make a choice and stick to it. Me personally, I like this one a lot better. There are some textbooks that prefer this way too. The reason I like this one a lot better is because I can extend it over to things like this. What if I have another function? Well, u prime v w and u v prime w and u v and w prime. You can easily extend like this. The derivative of the first function and then the other, and then the derivative of the second function and the others, and the derivative of the third function and the others. What if you have 4 functions? Well, pretty much the same. In that case, I'm going to really run out of characters. U, V, W, and then what do I do? Okay, all right. And then that's going to be U prime VWZ plus U V prime WZ plus U V W prime Z plus U V W Z prime, like that. The first factor is a derivative, second factor is a derivative, third factor is a derivative, fourth factor is a derivative, and then we add them all up. 4 factors, so we have 4 things added. 3 factors, so you have 3 things added. 2 factors, you have 2 things added. Well, these complicated things students usually do not miss. But something simple here, and I see this a lot. If you have just one thing here, nothing added, something is not right. We have 2 factors, we have 2 bunches added. I have only 1, it doesn't work this way. The derivative of product is not product of the derivatives. And the same goes for quotient. Derivative of quotient is not quotient of the derivatives. It doesn't work this way either. That's wrong. Instead, we have something heck of a lot more complicated. What do you have here? Let's expand the font so that you can read better. The denominator is squared, v squared. That's so conspicuous that not many people miss it. The numerator here, u prime v minus uv prime, is the very same as this except for the sign, plus becomes minus. Once you keep it that way, then you're not going to lose this. Still, I see a lot of students getting mixed things up. Okay, let's go to a couple of examples here. What's the derivative computation here? Well, the derivative first function, that's u, and that's v. So, oops, it's going to be this form, u prime v plus uv prime. So the derivative of the first function times the second function, first function, and the derivative of the second function. That's the structure. Derivative of the first function, we're going to put it in soon. The second function, well, let's just copy and paste it. First function, let's just copy and paste it. Well, that's the structure. The derivative of the first function and derivative of the second function. Okay, alright, basically what you did is to reduce a difficult problem into two easier problems. The derivative of the first function, okay, let's work it out. Derivative of w is just 1, and exponential always stay the same, and that completes the derivative of the first function. Now, derivative of the second function here, 3, that's constant, so it goes to 0. And then that's the same as 1/2 power, so 1/2 w to the negative 1/2 power after subtract 1. That completes the derivative computation. You don't have to simplify. Please do not simplify. Let's do this again. This time, some simplification is in order. We have too many traditional expressions. If you have power forms, then it's a lot more convenient because you can use power expressions, the power rule. So let's simplify like this. X squared plus 3x, so far so good. Instead of 4 over x cubed, 4x to the negative third power. Now instead of 4 square root of x, we have x to the 1/2 power. And this one here, 1/4 times x to the negative 1/2 power. Why negative? Because it's coming from the denominator. Why square root? Why 1/2? Because it's square root. So that's a simplification, the power form. So that's g of x. I didn't apply any of the derivative rule. Now, what is g prime of x? The derivative? We have a product here, so we have to use the product rule. U prime v plus uv prime. So u prime, the derivative of the first function, times the second function, and the first function times the derivative of the second function. That's the structure. So what did I do? I just reduced a difficult problem into two easier problems. Well, before that, we did some preparation here, converting everything to a power form. And by now, I hope everybody got comfortable with power form. If you are still not, well, keep working on it so that by the time you take the exam, changing anything into power form becomes so easy that you do not get exhausted. Alright, let's go ahead. The derivative of the first function. X squared becomes 2x. 3x becomes 3. And then minus 4x, and then multiply by coefficient negative 3, x to the negative 4 power, subtracting 1 from the power. Not negative 2, but negative 4. So negative 4 times negative 3, that's positive 12. So that's the derivative of the first function. Does it look good? X squared became 2x, 3x became 3, negative 4x to the negative third power, multiply negative 3 times negative 4, that's positive 12, and subtracting 1 from the power, x to the negative fourth power. All good. Now let's work out the second function. 4 is a coefficient, and multiply by coefficient 1/2 x to the negative 1/2 power, because I have to subtract 1 from the power. And what is this? 4 times 1/2 is 2. And 1/4 is there. And then multiply by -1/2. And then x to the, subtracting 1 from the power, -3/2 power. Let's see. -1/4, -1/2. So we're going to get positive 1/8. And that's the derivative of the second function here. Let's see. Is this right? Multiply, so 2, and subtract 1 from the power, so 2x to the -1/2 power. Good. Multiply -1/4 times -1/2, positive 1/8. Good. And subtract 1 from the power, -3/2 power. That's complete. All correct, and do not bother simplifying. Keep the structure. U prime v plus uv prime. Here in this course, I'm using this bracket expression for the derivatives. And then parenthesis, just copy and pasting. And that is not really a universally accepted notation. I just do it this way. But it helped me avoiding confusion. Whenever I see bracket and there's some blank there, oh, I'm going to have to do some derivative computation there. Whenever I see a parenthesis, oh, I complete it. No worries. Stop the playback and try this on your own. Exponential function times log function. What do you have? Well, here's the answer key. Derivative of first function, same, second function, plus first function times the derivative of the second function. You don't have to simplify, but if you do simplify a little bit, here we go. So those are the product rules. The answer key is here. And that too. The answer key here. Okay, let's just consider the quotient rule, but do we have enough time? Probably not, so let's stop here. And let's come back and discuss quotient rules in a separate video.